Hi, good day to another physics class. Welcome. So let's continue the topic gravitational field. The last class we talked about the force of attraction between different masses as well as the formula given by F, which is the force, G, the gravitational constants, M1, M2 are the two masses involved in the force of attraction. So today we are going to move forward to another aspect of gravitational field, which is the relationship between this G and this capital letter G. Apart from the fact that both are letter G, what did you also notice? One is a small letter, one is a capital letter. No. Now, this is the acceleration due to gravity. They are both interrelated. But this one is the acceleration due to gravity, tending to pull an object thrown up. Can you see? There is a gravitational pull trying to pull this object down. Why is it that when you throw a baby hop, why can't the baby just hang up? You have this scared, oh, my baby is up, why is it not coming down? That is a normal phenomenon. The baby has to come down because there is a gravitational pull between that baby and the heart. So the baby has to come down. Look at, my marker has to come down. But here is the gravitational constant. So relationship between those two is given by the formula G equals to capital letter G, the mass involved, which is my marker, and the radius, the distance. The distance. So now let's look at this question. Determine the mass of the heart if the radius of the heart is this. The parameters given to us, our R is this, 6.38 times 10 raised to the power 6. Our small g, we're told to use 9.8. And our capital letter G has been given to us in the question. So now let's go. All you just have to do here is to make sure you make your M the subject of the formula. So making M the subject of the formula, we'll be having something like this over capital letter G. Is that taken? Now let's include our parameters. We're told to use 9.8. What is our radius? Since it is square, it's going to be in two places. 10 raised to the power 6, 10 raised to the power 6. 6.38 times 10 raised to the power 6. Everything over capital letter G, 6.67 times 10 raised to the power minus 11. Is that taken? So now let's use a calculator. Let's apply the law of indices. Why I love applying the law of indices is because of the cumbersome indices. It will be easy for you to be using the calculator to multiply all this. So let's just apply indices, the law of indices. Now let's take this one. 1, 2, 3. Let's multiply it together. 9.8 times 6.38 times 6.38. So we'll be having a total of 398.9. Let's just approximate 399. 399. Now the indices, we are multiplying. So you add up the power. That will be 10 raised to the power 12. Over 6.67 times 10 raised to the power minus 11. Now let's divide that, 399 divided by 6.67. What do we have? We have 59.8. Now, you are dividing. So what will happen to this power? This minus, when it comes up, it will change to a plus because you are dividing. So that will be 12 plus 11. And that will give us what? 23. Now let's write it in an appropriate standard form, which is what? 5.98 times 10 raised to the power 24. We are looking for the mass, so this will become kilogram. Is that taken? That is our final answer. Okay, let's look at the second question. Here we are talking about gravitational potential. We are talking about what? Gravitational potential. And in this regards, we are looking at this formula V equals to Gm over R. Gm over R. Now, what is our capital letter G? We are given in the question Gm over R. Our G is 6.67 times 10 raised to the power minus 11. This is the formula you use to calculate the gravitational potential. What is our mass? Given in the question 5.98 times 10 raised to the power 24. Over, what is the radius? 6.38 times 10 raised to the power 6. Let me demarcate this place. Okay, so now still using the law of indices. Let me adjust the lens. So we have 6.67 times 5.98. What would that give us? 39.88. So let's approximate to 39.9. So we have minus 11 and plus 24. So this will give us what? 13 over 6.38 times 10 raised to the power 6. Can you see the way I'm applying my indices? Can you see I don't have to start pressing 0.00000 in 11 places? So now let's divide 39.8. 39.8. Let's divide it by 6.38. And here we'll be having 6.224 times 10. Because you are dividing, what will you do to the indices here? To the power. 13 minus 6. That will give us 7. This gravitational potential is measured in joules per kilogram. Simple. Can you see the way I applied my law of indices? The power are too large. You don't expect me to be multiplying this by this 0.0000000 using the calculator, and this one raised to the power 24. That is 598000000 using the calculator. No. So just apply the law of indices. And you just what? If you are multiplying here, you have the power. If you are dividing, you subtract the power. Simple. Alright, so we see next class. Ciao.